Good morning. We have talked about quite a few circle things so far. So if you've gone in order at all, we talked about arc length and sector area using circumference and area, and then we talked about the arcs and angles and how they're related in circles. So we talked about central angles, and um, we talked about inscribed angles and when the vertex of the angle is in, out, or on of the circle. And now we're going to talk about kind of the same look of things, but this time they are talking about segment lengths. And that's a major difference. So make sure that you see the difference between finding an angle and a segment, and I'll try to make that pretty clear for you. So special segments in circles, there's going to be two main ways you're going to see it. You're going to see where the segments are totally inside the circle. So it's made of two chords. And I just realized I don't have the colored markers that I needed. What do you think? All right, so when you have that, each segment has two pieces. So there's the pink segment with two pieces and the orange segment with two pieces. And so the way you figure out missing length is piece times piece of one of the segments. So let's say the pink segment, that should be pink, equals piece times piece of the other segment. You just multiply these two pieces times each other and these pieces by each other. And that's it. That's how you do it. So you can see down here it says PP equals PP. It's just a funny way to remember it. If the vertex is inside, it's PP. You want to hold the PP in. That sounds ridiculous, but hopefully it'll help you remember. You want to keep the PP in, so it's inside the circle, and you multiply piece times piece equals piece times piece. The other ways that you'll see it are when the vertex is outside of the circle. So something like this, those are called secants, or something like this. So this is a secant and a tangent. Remember, a tangent touches a circle at exactly one point. So this would be an example of a tangent and a secant. All right. And again, we have two different segments. So we have one and the other. And to figure out missing segment lengths on this, you multiply the outside piece of one times the whole thing. Time equals the outside piece, of one times the whole thing. So, for example, we would multiply the outside times whole of the orange, and that's equal to the outside times whole of the pink. So let's look at some examples. Again, I put ow, ow for that. Outside, ow, ow. Okay. All right, so let's look at these examples. Let me blow them up a little bit. Okay. And I'm just going to color these because if you get into the habit of color coding things, it makes it easier to know what goes together instead of trying to guess and remember the rules. All right, so this is inside. So we're going to use PP equals PP. Piece times piece equals piece times piece. So we can do either orange or pink first, but I'm going to do pink. We have x and 28, so 28 times x equals, and then you do the other one, 7 times 12. So piece times piece of the orange equals piece times piece of the pink. All right, and then we just do that math. So 28x equals 84. X equals 3. And the instructions say find the value of x, so we're done. All right, so this is inside. This is an example of outside. Since it's outside, we're going to do ow equals ow. Outside times whole of one equals outside times whole of the other. And this does get a little bit confusing, so let's look at it. For this segment, well, actually, let's look at this one first. For the orange segment, the outside piece is 12. But the whole thing from here all the way to here is 32. We did 20 plus 12 is 32, segment addition. All right, so that's for the orange side. For the pink side, the outside is pretty obvious, 15. But the whole thing, what would that be? What do you think? Most people's first inclination is to say 15x. But over here, that doesn't make sense, does it? We did 20 plus 12. So we're going to do x plus 15 for the whole thing. All right, and we're going to distribute and simplify stuff. So right now we have 15x plus 225 equals 384. And then you know how to solve. All right, so when I solved it, I got 10.6. And I will be honest and say the first couple times I do this, or the first time I do it each year, and I get 10.6, I'm like, wait, what did I do wrong? And I go back and I check everything because we like to get nice whole numbers for answers. But fractions and decimals are numbers too. So if you get it, you can go back and check your work. That's never a bad idea. But it's okay to get decimals for your answers. And again, we're going to make sure, find the value of x. We found it, so we're done. All right, and one more, find the value of x. I'm going to color code these again. We have an orange segment and a pink segment. And hopefully you can see that this is outside of the circle, so we're going to use ow equals ow. All right. So for our pink segment, the outside is 6. The whole thing from here all the way to here would be, hopefully you said x plus 6 in your head, equals the outside piece of the orange times the whole orange. All right, so again, we're just going to solve. All right, now I'll go back and put in those steps. I thought maybe I'd run out of time. And since it says find x, that's it. We're done. Okay, these are the simplest examples of special segments. It's either inside PP or outside ow ow. Okay, we're going to practice some harder versions in just a second. So I'm going to stop this video and make a second video with the harder examples.